Hello everyone, welcome once again to our channel. Today we are going to do chapter number 2, which is inverse trigonometric functions. Okay, as you know that trigonometric functions are periodic in nature, so they repeat themselves after a fixed interval. Now, in order to find the inverse of the trigonometric functions, we have to restrict the domain and the range. Okay, so that we get a 1 1 and onto function, because in the previous chapter, from the number 1, do you remember the result that f inverse exists for a function f if and only if the function is 1 1 and onto? That means the function f should be a bijection. Only then you have f inverse. Okay. Now for the trigonometric function, as we know that these are periodic functions, so we have to restrict the domain and the codomain to make them to find the inverse of that trigonometric function. So let us first see the graph of some known trigonometric functions. Okay, now let's see the inverse of the function. First, take for sine x. Okay, y is equal to sine x. As you know, the domain of this function is the whole real number. R, you can take the real number line minus infinity to infinity, and the range is -1 to 1. Okay, now let's see the graph of this function. So you have the graph is, this is a periodic function. So the graph is, the peak value is 1 and the lowest value is -1. Okay, so this repeats after every interval. Now when we want to find the inverse of this function, we have to restrict the domain and the range. Okay, so if I hold this graph like this, okay, so because when you take the inverse of this function, the x-axis become y and the y-axis becomes x. So in this case, when you take the interval from minus pi by 2 to pi by 2, the value you get like this, okay, that graph, that curve is actually the inverse trigonometric function. That value is actually the principal branch. Okay, let's see this. So when we take the range and domain of the principal value branch, so it will look like that. Now in our inverse function, because we have restricted the domain is restricted. Now the domain is from -1 to 1. Okay, this is for sine inverse x, and the range of this becomes minus pi by 2 to pi by 2, because only we want that part, okay, that principal branch. If you repeat this branch over and over again, you will get the complete sine x graph. Okay, so this is how we get, you have to just take a slice of the original one, you will get this principal value branch.